Okay, so Ron Francis is a self-trained Tasmanian-born painter who has exhibited since 1980. After a long stretch painting trompe-l'oeil murals from 1988 to 2006, he returned to fine art painting. Rod now exhibits with Scott Livesey Gallery in Melbourne, and a selection of his haunting paintings can be seen on his website, francis.com. Ron says, I work mostly from imagination, inventing scenes and trying to make them as real as I can. This causes me to study how things work in the natural world, particularly how light interacts with objects and environments, so I can more easily recreate it on a canvas. Subjects vary considerably from one painting to the next, ranging from recreating past events or dreams to comments about what I may find odd or ironic about the things people do. So it's a great pleasure for me to introduce Ron Francis, who's a painting I've admired for a long time, and I think you'll find his approach to calculating colour very interesting. Thanks, Ron.
Thank you, David. My main aim throughout my life is to be able to create a realistic rendition of anything I may imagine or dream. And controlling color plays a huge role in being able to do that. So what I'm going to do is go chronologically through the systems I've used to try to do it. During this talk, I'll refer to color in three terms, which has been touched on previously: hue, value, and chroma, where hue is how red, blue, or green, yellow something is. Value is simply how light or dark it is on a scale of 0 to 10. And chroma is how saturated the color is, so that gray has no chroma. And fully saturated red has high chroma. So I started with a red, green, blue color triangle. This represents colored light that would be lighting your monitor, for example, at the moment. And what I did was, if I imagined graduating between orange and blue, I would suppose that the color would be somewhere along this line. So from this, I can predict that if I was going to mix a range of colors to go from orange to blue, I would need to go through a mid-chroma red and a mid-chroma magenta. In this place, I'd probably get away with just a mid-chroma magenta. So the first painting that I experimented on this is a very early painting where I had a blue cyan light for the whole painting, and I had this orange light in the middle of the clouds. So on my color map, I predicted that I would have to mix a neutral gray as a bridging color between the two. So what I've got here is the cyan blue color here, the orange color here, and this color in the middle here would be neutral gray. This experiment gave me confidence that I was on the right track, and I continued. This is another early painting where I naively thought that moonlight was blue. So I'm trying to simulate moonlight. What I did achieve with this one, excuse me while I refer to my notes, the fence color, the vacuum cleaner color, and the color of the slippers. Hopefully it looks a little bit brownish, a little bit reddish, and a little bit pinkish. But these colors are actually low chroma purple blue. This is low chroma purple blue, so is this slightly different. And this is just low chroma blue. So this is an example of color constancy that we've talked about earlier. And the reason that that works is because the whole painting is so blue-purple, your eye wants to see the opposite color. So pushes these colors, because these are lower chroma, pushes these colors towards the opposite color. I migrated to this, which is a subtractive system. It's much the same. except that rather than adding lights together, it simulates coloured light sources on objects that are absorbing wavelengths and reflecting others. This is from a memory I had as a child. This is all constructed, by the way, except for the boy and the bed, which was from the photograph. I painted stars and galaxies on the floor, ceiling and walls. And what I want to point out here, I guess, is the luminance of the green. The reason that looks like it's glowing is if it wasn't glowing, that color would have to be darker than the white of the bed sheets. So the simple fact that it's lighter, and in context to everything else, it's lighter than everything else will make it look luminous, regardless of its hue and chroma. But as well as that, the green is opposite to the general color of the painting. So that's also making this green look a lot more saturated than it would if it was in isolation.
Can I just break in there for a second? You're not able to go full screen with this presentation?
I could go full screen, but as soon as I get to the animations, I won't be able to continue. I can do it for a little while, and I think I'll just have to muck around a bit. I've forgotten how to do it in this. Can I do it here?
I just wanted to address that. That's all. So it's up to you whether you.
I think it's going to make it more difficult. I hope this is enough.
I think it might be. May not be you, Ron. I'll look at that. Don't worry about that. Please go on.
Okay, I'll continue. This simulates incandescent light. What's happening here is that light is bouncing off this yellow-orange carpet, which is multiplying the chroma. And so it's making it more chromatic. And the light bouncing off here is illuminating this white ceiling and the white fridge. David talked a little bit about this. It's actually hard to describe. I would say that this color is the same as this color, but a darkened version. Even though it seems whitish, or I hope it seems whitish, it's actually the same color, but darkened. Also the walls hopefully appear purple-blue. What I've done in the next slide is I've isolated this bit of ceiling and this bit of wall to show you what colors they actually are. So as you can see, they're really quite browny, orangey. So again, this is color constancy at work, pushing colors in our minds to make them look like they're different colors. Here's another example of how I work or how I think when I paint. I've got the blue of the sky. I've got green grass that you can't see. I add those two colors together and then illuminated the shadow part of the building. So in this case, I'd be thinking something like this bit of timber up here is occluding the light from the grass. So just above it, shadow is lit by the blue sky. So it's only the blue sky color. Likewise, the further up under the eaves is going to occlude the light from the sky and only be lit by the grass color. Now, as I've mentioned, hue and chroma, I can sort of work out using those color maps, but it doesn't address value at all. So in comes a Riley compression. This represents black paint, white paint. So this is the total range that's available to an artist. What this does is you can compress the color range up. You can compress it into any place at all, into any size at all. And in this case, black is compressed up to mid-gray. Mid-gray is compressed up to value 7.5 and white stays as white. Likewise, this can be compressed downwards. So in this case, this could represent a shadow. So white becomes mid-grey. If I wanted to paint white in a shadow and I use this compression range, I'd say, okay, white has to be value 5. If I want to paint a value 5 object, it gets compressed down to 2.5 and black stays as black. I don't think the Riley system was ever meant to be able to do this, but it can also be pushed up and out of gamut. So in this case, black becomes mid-grey, mid-grey becomes white, and everything above white, so everything above value 5 here gets compressed, pushed out of gamut and becomes white. Likewise, this can happen if we push things down below black. So I use this system here where if you look at this white skirting board, that skirting board is value 4.2. So everything in the lit part of this wall has to be compressed to between 0 and 2.4. I actually had a real model for this dragon and I photographed it and I could sample the pictures. So what I would do is get the color of the pixel, compress it downwards to the right place within that value range. So this would have to be a value range somewhere between 1 and 10, and I'd compress it downwards. And using the color maps, I'd also change the color to make it fit in with this bluish color. So that same thing happens with these darker shadows here. That's a different value range here. Everywhere's a different value range. That's how I was working at the time. This is a more accurate way to determine colors of local objects illuminated by colored light sources. It's simply, these are local colors down here. And this is a swatch that's overlaid over the top in multiply mode. So purely this color is multiplied with this color and it yields this color. And this can also be used for downward compression as long as the bottom value is 0. If you wanted to underexpose or overexpose or compress upwards, it's not going to be that useful. But I started using this method. So in this case, I would have a color of the sky overlaid over the color of the grass, which would give me this color. Likewise, I'd have the color of the sky and the grass color mixed together, overlay them over the local colors for the wall, and that would give me the results there. This painting is more subtle in that it's a low chroma blue light that I wanted to have coming from the TV, and there are no contrasting light sources at all. However, if you sample these white stripes, you'd see it's a low chroma purple blue. What's interesting about this is even at this level of low chroma, you get color constancy happening. For example, this nightshirt is neutral gray, but because everything else is lit by the blue light, it appears a little bit yellowish. Atmospheric perspective, aerial perspective is, so let me refer to my notes for a second, please. It's the effect that atmosphere has on distant objects. And there are two things that do this. One's Rayleigh scattering, and I'll talk about that a bit later, and the other is my scattering. My scattering is commonly caused by dust, pollen, water droplets, and smoke, and can be a variety of colors. In this painting, I just chose a low chroma greeny color for the fog. And I had the simple idea that if a foreground object was halfway in between its original position and the fog, or where the fog would obscure everything, the color would be halfway between its foreground color and the color of the fog. This isn't quite accurate, but it worked fairly well. Here's another example where I stepped into the painting 1 meter at a time. You can probably see little graduation lines there where I didn't mix it very well. And I would calculate the amount the fog was going to obscure the objects. This is another good example of color constancy. The blue mattress and the blue in the book are nowhere near blue. They're really very orange. By this stage, I started using the Beer-Lambert laws, which determine how quickly objects will be obscured. So what's happening here is, instead of the naive idea that halfway into the fog will be halfway obscured, objects get obscured in an exponential fashion rather than a linear fashion. Rayleigh scattering is much more complicated than Rayleigh scattering, than my scattering. It scatters blue light, and it's responsible for the sky looking blue and for sunsets looking orange and sunrises looking orange. The maths behind that is extremely complicated and involves ray marching and integration along many, many rays. It's above my head, but I was able to find some code online and incorporate it into my code. Like Andrew, I use C++ programming computers, but I learned to program to help my art rather than having a background in art. Anyway, this is the first painting where I used Rayleigh scattering. You can't see it all that well because it's not a far distance, but all this background is bluer. I've also used a little bit of my scattering to put some water vapor in the car. This is another attempt at painting moonlight. I had learnt that we lose our ability to see colour as light dims. So what I did here, I think I had a low chroma green light just for aesthetics and worked everything out as normal, but then I finally just desaturated the colours. By the time I painted this one, I'd realised that we lose our ability to see red and yellow before green and blue. So once again, I used a blue light. This time I worked out, I just worked out everything with a blue light and desaturated everything afterwards in a similar way to the last painting. What's of interest here is the color of the bricks is actually very, very close to neutral. And I think what helps the illusion is this little bit of light up here where your brain says, oh, look, they're bricks. And you can make up a bit of color in your mind as well. This is one of my favorite paintings. Here I used Fresnel equations. Fresnel equations determine how much reflection you're going to see of something depending on the angle your eye is making with the object. So here the water, up here your eyes a more acute angle with the water, so you see more sky reflection. And likewise, what I was particularly happy with here is I did it on this crocodile. I'm trying to get away. Here we go. So these planes here that are facing more away from the eye are receiving more reflection from the sky, and the ones facing the more to the front don't. The white glistens on there were just done intuitively. This is just another example of shards of glass reflecting the background from a much larger painting. I've added this one as a curiosity. I worked out the lighting in this, the way I worked it out, it's called global illumination in the CG world. So what I would do is I'd pick a point on a surface and I'd shoot out rays in random directions, thousands of rays. And the number of rays that would reach the sky would tell me how much light was hitting that object. So if I come up here, for example, and shoot out rays, a lot of them would be occluded by the eave. And so I would say, okay, most of that's being lit by the light from the ground, reflected from the ground. More subtly, the foreground grass gets darker as it goes towards the house because the house is occluding light from the sky. And around here. It was a very tedious way to work, but I thought it was pretty successful. Now, I migrated from those color maps and the Riley system into X, Y, and Z. This looks like a RGB color cube for just so it's easier to see. This completely replaces the Riley and the color maps and the color editing programs in that I can translate and scale this in exactly the same way as the Riley system, but it retains color information, so it basically does everything. I just want to explain that a little bit. I'll just go back here. So if you, sorry about that, stop. So if you imagine this is black and this is white up here, and that there's a color scale going from 0 to 10 up here, that would be equivalent to the Riley compression. In this painting, I didn't use any compression or translation of the color space, but I used a light that was out of gamut for the reflection on this gold building. I also used Riley to work out the color of the sky. I used Fresnel equations to work out how much reflection, and I used a little bit of my scattering in there. I didn't think this painting was particularly successful, but I was very happy with the gold building. This was a more successful attempt at luminosity. I wanted to make the TV screen look luminous. So what I did was I moved the whole color space upwards to between value 3 and 13. So what this means is that any value, oh no, I'll go back. I found an image online of a game show, and I could sample the pixels. If that pixel had a value of 7 or higher, it would get bleached to white. And other colors were often the highest chroma that they could be for the value that they were. The rest of the painting is just, I have another light source back here that's more orange, so there's a difference between the orange. That's just a contrast. Having done that other one, I wanted to push it to more of an extreme. So this color space was pushed for up to 5 and 15. So any value above 5, we get bleached to white. These rocks are all pure white, except for a little bit of shading where it goes around the edges. And the idea was to push the color space up enough so that the colors in the shadow part of the hazmat suit would be as chromatic as possible. Obviously, there's my scattering in there. There's no Rayleigh scattering because I was looking at images of Mars for the landscape. This is the final painting I'll show you where I used nearly all the techniques in one go. I used a color that was out of gamut for the lighting in this little bit of spotlight. I mixed the color of the spotlight with the background in an additive mode for the particles. I used I used Fresnel equations to work out how much reflection I wanted on the pavement and also in the glass in the windows. And I used global illumination to work out, where all the shadows were going to go. Finally, I want to show you the software that I've written to handle this sort of stuff. This one handles perspective, and this workspace is the picture of the crocodile that I showed you earlier with the children. This red dot is sitting on the water, and I don't know if you can see it, but I've got data over here in my window. It's covered up by people's pictures, but I've got data in there that says the distance, where the point is in space, the angle of the light, the brightness of the light, and the radiance of the light. And this information is passed to this program. It's very similar to creating a color spreadsheet in a photo editing program. These are local colors down here, and these are what I call shaders. In this case, this is the color of the light source, and there is some upward compression built into it as well, and some upward translation. And that's why these colors here are lighter than these colors. Over here, I have the color of the ground. So any downward facing planes would be illuminated by this color. This is purely a multiplication between this color and these colors. So there's no downward compression, and it gets compressed downward automatically just by the multiplication. Likewise, the sky color for any upward facing planes is working exactly the same way. This column is in between these two, so it's a combination of these two lights, and I've darkened it to simulate surrounding bushes, etc. It's a bit difficult to see, but this column interpolates between the sunlit color and the shadow color, depending on the inclination of the plane away from the light source. I can't remember what I use this one for, but this one is the Fresnel, where I've got the color of the sky. Down here, I've got the color of the water, and the intersection point is the color that I need to mix. Down here, I've got color spaces, and I have the Munsell color space here. So this color is converted to Munsell, and Munsell gives me a physical colors that I can mix and match to, that I have next to my palette. In conclusion, I'd just like to say that when I was a child, I remember painting by numbers, and it seems like I've gone full circle back into my childhood, and I'm painting with numbers again. Thank you all very much for your attention.